So last time we talked about proofs. What is a proof? What is not a proof in terms of mathematics? And one thing about mathematical proofs is they have to be very precise. So that's what we're going to talk about. How do you make your proofs precise? So the next few videos, that's what it's about. I know you think of geometry, you think of points, lines, planes, and that is very important for geometry, but there's more to it. You got to know the logic. So we are going to talk about logic in the next few videos. That way everything is nice and tight. So I'm going to actually start drawing from the composition book. Everybody should have a composition book. This is mine. I went ahead and I got a blank one. So I'm starting from scratch, just like you guys. And the first thing that we're going to do in here is we are going to talk about logic. So we're going to talk about conditional, converse, inverse, contrapositive, several different things. And in your composition book, you can use whatever color markers you want. You can just do it in pencil. You can do it in pen if you want. I hate pen, but okay. If you want to do it in pen, it doesn't matter. Okay, you can make it look as nice as you want. You can write as much as you want. But usually on these videos, if I take out a composition book, that is something that you need to write in yours. All right, so I got my composition book. Okay, so let's get back to logic. Let's have some fun here. So logic. The other day I saw a cartoon, and it actually reminded me of this. Most cartoons don't actually make logical statements, but this one did. This cartoon, the title, it was called All Dogs Go to Heaven. All right, All Dogs Go to Heaven. Now, the title of this movie, if you haven't seen it, it's actually a pretty good movie. The title of this movie is called All Dogs Go to Heaven. This is a statement. So a statement is this. A statement is something that it's either true or false, but it's not both. It's either true or false. So your very first definition. So I'm going to say a statement. A statement is this. It's something that is either true or false. All right, so a statement is either true or false. It's not in between, it's either true or false. Okay, that's a statement. So this right here is a statement. Either all dogs go to heaven or not all dogs go to heaven. Right? It doesn't matter if dogs exist, it doesn't matter if heaven exists. I'm pretty sure dogs exist. I have 2 of them at home. Heaven, I've never died before, so I have no idea. Who knows? But a statement is something that is either true or false. And this statement right here, it can either be true or false. In fact, in the movie, a dog actually died and did not go to heaven at first. So that would make it false. We call that a counterexample, and we are going to get into that later. But before I do that, let's slow down here. So that's what a statement is. Now, the most common statement is called a conditional statement. So that's the next thing I'm going to write, conditional statement. Conditional statement. And I'm going to underline it because this is important, conditional statement. A conditional statement says this. It says P implies Q. So that little arrow right there means implies. So I'm saying P implies Q. Now, how can I relate that to this? This is actually a conditional statement up here. It doesn't look like it at first, but we can rewrite it to make it look like that. Let's see. So I could say if X is a dog, then X goes to heaven. I think that's right. I don't know. Be honest, I forget how to spell heaven all the time. I don't know. All right, so if X is a dog, that X goes to heaven. All right. These are the two big important words, and I'm going to circle these because this is important. If and then. All right? If and then. If blah, 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 then blah, blah, blah. That's the conditional statement. Now, the first part, the if, this part right here, that is the hypothesis. So hypothesis, it's supposed to be an S. So the first part is the hypothesis. The second part is the conditional. So this is the, I'm sorry, not conditional, the conclusion. I'm getting my C words mixed up. This is the conclusion. That is the conclusion. All right, so we have hypothesis and conclusion. Hypothesis is what you start out with. You say, if this is true, then this is true. If P is true, then Q is true. That's a conditional statement. P implies Q. If this is true, then this is true. So if X, and X can be anything, it could be a house, an elephant, whatever, I don't know. But now it says if X is a dog. Okay, well that narrows it down. So I'm not talking about houses or elephants. I'm talking about dogs. So if something is a dog, if that is true, then it's also true that that dog goes to heaven. So if and then, that's a conditional statement. P implies Q. All right. Now I can switch things up a bit. Notice this right here is my P. If X is a dog, that's the P. Then X goes to heaven, that's my Q. I can actually do a few things with this. I could switch the order. I could also take the negation. A negation is basically saying not. So the negation of me saying, I'm having a good day. Well, the negation is, I'm not having a good day. That's what negation means. All right, so let's see. So we can switch it up here. Let's go ahead and switch up the order. We'll get into the converse. Let's do the converse. All right, so a converse. So next line here, and I'm going to have to move this camera a little bit here because my Chromebook is in the way. There we go. All right, so next line here. Let's do the converse. So this is the converse. And I'm just going to use the same example throughout. It's easier that way. So what is the converse? The converse is this. The converse says Q implies P. So if Q is true, then P is true. If the conclusion is true, then the hypothesis is true. Because remember, on this one, we're saying that P is the hypothesis, Q is the conclusion. So Q implies P. That's the converse. So let's see if we can actually rewrite this. We said if X is a dog, then X goes to heaven. So the converse would be I just switch these two around. I don't take a negation. I just switch them around. That's all I do. So if I say if X goes to heaven, let me write that out. If X goes to heaven, then X is a dog. All right, now let's think about this here. The converse says this. If X goes to heaven, then X is a dog. So anything that goes to heaven must be a dog. Does that make sense? Is that what our original conditional statement is saying? The original statement says that if X is a dog, then X goes to heaven. But if I take the converse, if I switch those two around and come to this, now I'm saying that anything that goes to heaven must be a dog. That's not what we were talking about here. All right, that means houses don't go to heaven, people don't go to heaven. I mean, depending on your religion. But I'm just using the, conventional Judeo-Christian version of heaven here. And in that one, it's people are what go to heaven. So this doesn't really make any sense. This basically says that only dogs go to heaven. Nobody else goes to heaven. No other animal, no other object goes to heaven, only dogs. That makes no sense. And that's important because the converse is not always logically equivalent to the conditional. So conditional, I'm going to write this down because this is important. Conditional is not logically equivalent to the converse. Sometimes it is, and we're going to get to that because there is a special case when these two are equivalent. There are cases where if this is true, this is also true as well, where both of these things are true. All right, there's a special case for that. But don't just assume that the conditional is always logically equivalent to the converse. Okay, I'm going to say not always. Not always. All right, so that's the converse. Now let's do the next one, the inverse. Inverse is where we talk about negation. Remember I said negation is when you take the opposite of something. The negation of me having a good day is that I have a bad day. Negation is the opposite. All right, so let's do the inverse. So the inverse would be, now we started with P implies Q. We're always going to start with that. P implies Q. The inverse is if I say not P implies not Q. So not P implies not Q. This little squiggly line here, when we talk about logic, that means a negation. That means not. So you would read this as saying not P implies not Q. Right? This is the negation. And sometimes they'll use a different symbol. Sometimes they'll do something like this. They'll say not P implies not Q. Personally, I'm not a big fan of that notation. Sometimes they use it, sometimes they don't. But I wouldn't worry about that, just for your information. All right, so let's write this out here. So not P. So if X is not a dog, if X isn't a dog, then X doesn't go to, I'm running out of room, to heaven. So if you're not a dog, you aren't going to heaven. So if you're not a dog, you're not going to heaven. Notice that these two are actually kind of saying the same thing. And in fact, it is actually true that the converse and the inverse are always going to be logically equivalent. So I'm going to write that down here. So converse is logically equivalent. That's what those three lines mean here. Logically equivalent to the inverse. All right, so we have conditional statement, we have converse, we have inverse. Converse is logically equivalent to the inverse. And there's one last thing we got to cover. So I'm good on time, and I think I am. Let's turn the page here because we have another thing. This is the contrapositive. It sounds complicated, and it is a little more complicated. Get all the stuff out of the way here. This basket we'll just throw to the floor. All right. Now let's see here. Contrapositive. Let's see. Contrapositive. Gotta love the contrapositive. And I love the contrapositive because this is actually logically equivalent to the conditional. So a conditional is logically equivalent to the contrapositive. So a contrapositive would be, so we started with P implies Q, right? That would be the conditional statement. P implies Q. For a contrapositive, we're going to switch it around, just like the converse. I'm going to say Q implies P, but I'm also going to take the negation of both. So if I do these two things, if I switch the hypothesis and the conclusion around, and if I take the negation of both, guess what? That gives me the contrapositive. That gives me something equivalent to the conditional statement. And that's important because when you're proving things, sometimes it helps to write them in a different form. That's the whole point of all this. That's the point of why I'm going over these, the conditional, the converse, the inverse, and the contrapositive. Because sometimes you want to rewrite things to prove something. It makes it easier. But you have to know, all right, well, if I'm trying to prove, let's say, a conditional, then I don't want to rewrite it as a converse or an inverse because those two are not always the same. But I can write a conditional as a contrapositive. So let's write out what the contrapositive is here. So for the contrapositive, we started with, on the conditional, it was all dogs go to heaven. I believe we said if X is a dog, then X goes to heaven. So we're going to switch these two around, and we're going to take the negation. So I'm going to say, if X doesn't go to heaven, if X doesn't go to heaven, then, all right, well, what do we start with? What was our hypothesis? Because this we have to take over here. Then, okay, so X is not a dog because we have to take the negation of it. Then X is not a dog. Then X is not a dog. All right, perfect. That's the contrapositive. And once again, this is important, so I'm going to write it down. Conditional is always equivalent to the contrapositive. All right. So, conditional statement, converse, inverse, and contrapositive. Those are the four big deals. All right. And there's also one more. Let's see how much time we have. So I'm going to go ahead and make a part 2. I don't want to make these videos too long. So go ahead and look in the homework. Some of these you can already answer. Once you get to the, let's see, counterexample, biconditional, that's when you can watch the next video. All right, so this homework assignment is going to have 2 different videos. So just watch this one, answer what you can, and then look at the next one.